Okay, so number one, use sum and difference identities with unit circle values to find exact answers. So tangent of negative 105, we just want to find two unit circle angle measures that add or subtract to negative 105, and we want to use multiples of angles that we recognize, either 30, 45, 60, or 90. Okay, so tangent of negative 105, thinking of two numbers here, negative 45 and negative 60, that could work. We'll treat now negative 45 as A and B as negative 60.
Wait, but Mr. Yang, don't they have to be like positive? Because on the unit circle, there is no negative 60.
Right, well, we can build this out first, and then we can find coterminal angles that matches what we think is best with negative 60.
Okay.
But for now, let's just get this all spread apart and then get it out of this notation, and then we can work from it individually. Right, so negative 45, negative 60, it may feel strange, but we know that we can always find the coterminal angle that's equivalent to this by adding 360. So if I add negative 45 plus 360, okay, I get 315. And then negative 60 plus 360 is 300. Okay, so I can rewrite this tangent of 315 is tangent of 300. Okay, thinking about unit circle values, this is a variation of the 45-degree angle. So we know that tangent in the fourth quadrant is negative, and we're going to get -1 there. Tangent in the fourth quadrant is negative for 300 degrees. We know this is the variation of 60 degrees, and tangent at 60 is √3/1, so -√3. Okay, tan 315 and tan 300, we can just carry those over again. Okay, any questions there? Okay, cosine of 15. 15 is not a unit circle value, but I can think of two numbers that can subtract out to be 15. I can do, 60 minus 45. I can do 45 minus 30. These all work, and they're all going to get you the same answer. I'm going to just choose 60 and 45, but you can try 45 and 30, and they'll give you the same. Okay, so this one is a difference identity. So cosine of A minus B, we now want to take the bottom operation. That's going to spell out to be a positive on the right side. All right. Cosine of 60, half. Cosine of 45, 2/2. Sine of 60, 3/2. Sine of 45, 2/2. Okay, number 3, well, 3, 4, and 5, we're going to be using alpha and beta above here. So we're going to create 2 triangles. For alpha, we know that alpha is between pi over 2 and pi, so we know that is in the second quadrant. For angle B, between 3 pi over 2 and 2 pi, that's quadrant 4. Okay, so I'm going to draw 2 triangles here. I'll put it in this space so that some room to work with on the right. Okay. So for alpha, we know quadrant 2. Cosecant is the reciprocal of sine, so hypotenuse over opposite. Pythagorean theorem. Yeah. Okay, we're getting positive 12. Okay, you're always going to get a positive number when you're going through Pythagorean theorem, but we have to make sure that we know which quadrant we're in, and we're making the appropriate adjustment here. So I got to go left 12 and up 5. Left 12 is going to give me negative. Okay, we'll set that this triangle to the side here. Tangent of B is negative 3/4. This is in the 4th quadrant, so we'll go ahead and put B in the 4th quadrant. Okay, so tangent is negative 3/4. That's going to be opposite over adjacent, opposite over adjacent. We know the negative is going to have to be with the y because we're in the 4th quadrant here, so negative 3/4. Pythagorean theorem, your hypotenuse is always positive, so in this case we can keep that positive. A squared plus b squared equals c squared. Okay, so everything that we need is from these 2 triangles. Let's find sine of a minus b. Expand this out. All right, sine of a, I'll pull this from the first triangle here. So 5/13. The sine of b, 4/5. Cosine of a, 12/13. Sine of b, 3/5.
The thing is upside
Oh,
down.
sorry about that. Change this.
The test.
You want to work into first period?
Maybe I could start it now, and if I run out of time, I could work into like advisement.
That's fine. It's just I can give you. There's 3 pages to the test.
Okay, maybe you give me one to start.
multiply that together. 13 times 5 is 65. Cosine of b plus a. Common denominator here. A 412 is reduced to be 1/3. Dividing by a fraction is the same thing as multiplying by the reciprocal. (48) and 3 can keep reducing here. 16. All right, good on the first page. Okay, back page.
Hello, all teachers. The French National Honor Society is serving breakfast.
Okay, so first is we got to decide which quadrant we're in. So sine is negative and cosine is negative. I'd like to go through this little diagram here. All Trig functions are positive, only sines positive, only tangents positive, only cosines positive. So here, sine and cosine are both negative, so that's going to have to be tangent, right? So third quadrant, tangent is positive, but everything else is negative. Build our triangle in the third quadrant. Sine is -3/5. Sine is opposite over hypotenuse. Pythagorean theorem, a squared plus b squared equals c squared. You're going to get the 4, but you got to make an adjustment because third quadrant, both x and y are negative. So I got to go left 4 and down 3. Cosine of theta plus pi over 3, we can go through double angle. Oh, sorry, some identity here. Cosine of theta times cosine of A, cosine B. All right, so cosine of theta, we can use the table here. Cosine of theta is -4/5. Cosine of pi over 3, that we can pull from a unit circle. That's just 1/2. Sine of theta, sine is given here, -3/5. Sine of pi over 3, we can pull this from our unit circle, √3/2. Okay, tangent of 2 theta, expand that out. Double angle identity here. Yes.
The homework you sent out for 202.4, problems do you want us to do? Is it on the calendar?
Yeah, calendar. Okay, so tangent is opposite over adjacent, so 3/4. Denominator below. Multiply by the reciprocal. Convert this into 3/2 first if I want. Find the following. For 8, we'll just go through difference identity, right? Sine of A minus B. A would be pi, B would be x. Sine of pi, circle value, that's just going to be 0. Cosine of pi, that's going to be -1. 0 times anything is just going to be 0. So I'm just left with negative times -1. Two negatives becomes positive, so I'm left with the sine of x. Can't go any further than that. That's okay. For number 9, I can apply difference identity and sum identity twice. Well, once for each expression there. Difference identity, sum identity. So that's for the first part. Cosine 30 plus x, we can do sum identity there. Cosine of 30, we can reduce, or we can use unit circle values there. Combine some like terms here. The 1/2 sine x and -1/2 sine x, that goes away. And we got like terms there. Add those together. √3/2 plus √3/2. That's just 2 √3/2. 2's cancel out, just left with √3 cosine x. Any questions?
Back over to number 8. I'm confused, like where you got the 0 from.
Right, so sine of pi is a unit circle value. So if you look at sine of pi here, sine of pi, you look at the y value.
Yeah.
So,
So, I mean, that's
Killian, Youssef, you guys good?
Yeah, can you just go
Oh,
back
yeah.
down to 9 real quick?
Sure.
All right, I'm good. Thank you.
All right, great. See you guys in class.